Hello, my name is Peshawa Mohammed, and I'm a PhD student at Technological University Dublin. The title of my presentation is Integrated Geospatial Data Supporting 3D Land Administration Systems in Ireland, in which I am presenting my work on integration of BIM data with geospatial data in order to develop a 3D land administration system in Ireland. Over the past 2 decades, the population in urban areas has increased drastically and exceeded the population in rural areas. This caused a higher demand on the land in urban areas. This rapid urbanization and lack of available land in urban areas has forced decision makers to take advantage of space above and below ground. That's why we started to see more and more complex buildings all over the world. These are just some few examples. However, one of the disadvantages of having those complex buildings is their registration. The conventional 2D land administration systems has limitations in order to store all the legal, survey, and ownership information, especially for complex buildings and infrastructures. In the first photo from top left, you can see we have a multi-story building, and in order to store those information, we need loads of 2D plans, PDFs, which are not very efficient. In other cases, as you can see in the second photo from lower left, we have a building that's actually passing over another building, and just using a 2D plan might not be very efficient. And the solution for those problems is using 3D models. So in the first photo from left at the top, you can see we have a 2D plan for an apartment, and also beside it, it is the 2D plan for car park and storage area. This is the conventional method. However, we can use a 3D model in the in the first photo from bottom. You can see we have blue areas representing each of apartment unit, storage area, and car park area, all belonging to the same owner. And those information can be stored in a digital database, which is more efficient. And also we get the 3D visualization of each owner's properties. In other cases, having a 3D model also useful to know what is the lowest allowable digging level. For example, if we have a construction at the top of the ground and we have a tunnel underneath. So 3D models are very useful in those situations. The 3D LAS is not a new concept. Actually, several countries started implementing in their local cases. So on the map, you can see the green markers are countries that already implementing some sort of 3D LAS in their local cases. This includes Sweden, Norway, Australia, some Australian cities, some Chinese cities, the Netherlands, and Singapore. And the orange markers are the countries that are testing 3D LAS for their local cases. This includes New Zealand, Indonesia, Morocco, South Korea, Turkey, just to name a few. So the use of digital 3D model facilitates transition from 2D to 3D LAS. And BIM models are powerful for modeling physical and legal aspects of structures that can be used as actually is a suitable candidate to be used for 3D LAS. However, it is very important to note that BIM models must be of very high quality to be used in a 3D LAS in order to avoid legal disputes in the future. That's why it's crucial to validate the quality of BIM models before using it into 3D LAS. And BIM models must be integrated with GIS models for conducting spatial analysis on the 3D LAS. And finally, it's very important to use open data for increasing interoperability between different sectors, and also to meet the EU or international open data requirements. So IFC is one of industrial foundational classes. IFC is one of the most popular open data in BIM that can be used for sharing the BIM data within or between different stakeholders. In GIS environment, CityGML is one of the most popular open data 3D models, and in survey, land infra can be used. In the image, you can see those open standards, despite that they have overlaps between them in representing features, but actually each standard is unique and designed for a specific purpose. That's why combining those standards have substantial benefits. So regarding IFC, Industry Foundation classes specifies a comprehensive object model for describing a sharing building model, but also IFC extends beyond just representing physical building elements like walls and doors, but also it can represent construction schedules, activities, and costs. IFC provides three ways to represent volumetric objects. The first one is CSG, in which involves using Boolean operations such as union or intersection to create a new objects, or using sweep volumes, where sweep volumes basically in which we have a 2D plan and 2D object. We are just extruding that 2D object into a 3D, or maybe using BRIP, which is a boundary representation. It can also be used for representing objects in IFC. So as of August 2023, we have 3 official versions of IFC standard. The first one is 2.3. It is ISO certified, and it was published back in 2007. Then we have IFC 4.0. It is also ISO certified, and it was published in 2017. There are some differences between these two versions. However, one of the most important difference is in IFC 4.0 now supports associating geospatial data with IFC. It means we can georeference and embed georeferencing information into IFC models. And the last version is IFC 4.3. It is actually now it's under ISO examination. The main difference between this version and the previous versions is that 4.3 is more dedicated into representing infrastructures such as roads and railways. Regarding CityGML actually is mostly used for storing and sharing 3D city models, and it was developed by Open Geospatial Consortium. It is an XML based, so it is easily accessible and can be compatible with different other systems. And it's worth mentioning that CityGML is not about just 3D visualization, but also semantics and categorical properties and relationships between objects can be stored and transferred using CityGML as well. CityGML is exclusively depicted using a boundary representation, BRIP, and it has 5 levels of details. The first one is LOD0, which is self-explanatory. It's just a 2D plane. Then we have level of detail 1, which is a 3D box. Then LOD2 and 3 gets more detailed and more objects are represented. And finally, we have level of detail 4, in which internal objects are also represented. Regarding LAN infra, LAN infra actually is a relatively new OGC standard. This standard is developed, of course, by OGC, and it has the capability to store LAN-based administration information, also representing topography, subsurface information, and also surveying information. So LAN infra supports some features that are not available in CityGML nor in IFC. This includes supporting subsurface data modeling and also storing surveying information, which is very important. In the photo from right, you can see this is the structure of LAN infra, in which different sectors and fields can be represented into LAN infra model. So in general, we can say that we can divide data between geospatial data, which is data from GIS or maybe LIDAR, GPS, or maybe geospatial surveying or photogrammetry, and we have non-geospatial data. This includes BIM, if it is not georeferenced, of course, sensor data and post-occupancy data utilities. And if we combine those types of geospatial, non-geospatial data, then we could have a very high quality 3D LAS, and consequently, we could have a very high quality digital twin. And in order to combine those information, there are three main methods: either the conversion between these open data standards, or maybe integration between them, or using linked data techniques. Regarding conversion, it's mostly done using commercial softwares. Most popular ones are FME or ArcGIS, ArcGIS interoperability tools. However, it's worth noting that most attempts are unidirectional. It means from IFC to CityGML, and this can lead to information loss. And this information loss can be semantic or geometrical. On the right, you can see at the photo from top, we have an IFC model and we have CityGML model. And in order to transfer IFC to CityGML, firstly, we need to conduct semantic mapping, then geometrical transformation, and then refinement of this geometrical and semantic transformation, because IFC is a very rich model. The very rich model compared to CityGML. So there are certain objects that are present in IFC, but there are not existing in CityGML. In the second photo from the one at the bottom, you can see we have IFC on the left and CityGML on the right. And you can see that there are certain objects that exist in IFC, but they are not present in CityGML. That's why it is inevitable that we have information loss while converting. The second approach is integration of this data, and this can be done in two methods. First one is the bidirectional exchange. It means converting, let's say, from IFC to CityGML and then converting back, or maybe creating a new standard, a unified model. The unified model can be a mix of some objects in the IFC file and also some objects and entities in the CityGML to create a new standard, actually. However, one of the disadvantages of using this method is when we create a new model, then the softwares or the viewers might not be able to read this new standard. On the image, you can see we have this study. Actually, it has been done in 2012, in which the researchers created a unified new model called Unified Building Model that uses some IFC elements and also CityGML elements as well. And the final method is using linked data techniques. We're all familiar with Web 1.0, in which we are using hyperlinks in order to connect different documents. Then we have Web 2.0, the web that we are currently using, web pages. And then we have Web 3.0, and this uses semantic web, or as it's called, web of data. The semantic web was coined by Tim Berners-Lee in 2002, and it consists of four main elements. The first one is Universal Resource Identifier, URI. It means every object in our model must have a unique global identifier. Then we must have a resource description framework, RDF or triples. So you can see at the right, we have this graph predicting the subject, predicate, and object. So this subject can be any object in our model, then what's the property of that model and what's the value of that model. So if we are able to represent the whole model in 3D triples, then then we can create links between different objects and basically integrate different models with each other. Going back to elements, the third one is ontology web language. This is important because we need to have a standard language in order to represent those triples. And finally, we have Sparkle. It is a SQL query language that will allow us to query any information that we need from the graph that we created from 3D triples. Linked data is the basis for semantic web, and also, again, it was coined by Tim Berners-Lee in 2006. However, the disadvantage of using this technique is the initial implementation of this technique can be very slow process, especially at the beginning. So the main research question in my research is how to validate the quality of BIM models as potential inputs for development of 3D labs in Ireland. And the main research aim here is to develop a framework to validate the quality of these BIM models for development of 3D labs in Ireland. This includes validating internal accuracy, in which we are validating if there is any clash between different objects in the model, of there is to check if there is any gap, and the main aim is to automatically detect those deficiencies and fix them. And external accuracy basically is to enrich the BIM models with geospatial information and georeferencing information and integrate that with other GIS standards. So the validation, after it has been enriched, then we have to validate the geospatial capabilities of the BIM model as well. So the research is done in two stages, internal and external accuracy. So the main contribution and advantage of this research is developing a methodology, set of tools, and best practice to check the quality of BIM models in an automatic and semi-automatic manner. So the main aim is on 3D LAS, 3D land administration system, but by product, if we have a very high quality BIM model that is high quality internally and externally, and it can be integrated with different and other geospatial standards, then by product we could have high quality digital twins, urban planning applications, and also it's a step towards moving to smart cities. Because if we have very accurate BIM models and very accurate GIS models as well, that's integrated with each other, then in smart cities we could have applications for people that are partial, they have partial vision impairment, or maybe for navigation of robotics. Actually, the applications can be limitless in that case. The two more motivations for this research is BIM mandate in Ireland and also Project Ireland 2040. So it is mandatory, or there is starting from January 2024, all public projects that are over 100 million must use BIM in their projects. And also one of the main components of Project Ireland 2040 is Build Digital project, in which it aims to transform the Irish construction and built environment to be more digital and more sustainable. So assuming getting all those digital models, or getting all those digital models from these two initiatives, then it's very important to make sure that those models are of high quality, and also then it can be used for various applications in the future. Transitioning from 2D LAS to 3D LAS, using high quality BIM models can help geospatial surveyors to plan and perform surveying tasks on multi-level developments more efficiently in a shorter period of time. Tasks like mapping of registration of title to a parcel, title plan, and also mapping for defining legal boundaries. In addition, according to the latest boundary report, actually by Society of Chartered Surveying Ireland, it was published in April of this year, the legal boundary between leasehold apartment and freehold communal structure cannot be easily inspected and may be complex. That's why development of BIM model can influence this issue and solve those problems, which is one more advantage of this, one more advantage of developing 3D LAS. So this is the current registration process using 2D plan, and this is the future that we are suggesting. And 3D LAS also can be used for valuation purposes. So BIM models can be, or high quality BIM models can be used for calculating gross external areas, net internal areas, and also zoning. And finally, it is a step forward, as I mentioned, towards having digital twins and move toward smart cities in the future. Thank you for your time.